I'm Yoav Weiss. I work at Akamai on making both browsers and CDNs faster. And I'm here to talk about third-party content. And the reason I want to talk about third-party content is that our ecosystem is broken. You guys are coming to conferences like this, listening to people talking about performance, clearing out your critical rendering path, making sure your images are as small as they can be, making sure they're responsive. And then a business person comes along and is telling you to add this tag to your page. And this tag is adding another tag to your page, which is adding another one. And all these tags together are relieving themselves all over your hard performance work. And you are frustrated, and you are suffering as a result, and your users are suffering. But who's to blame here? The business person is just trying to do their job. They're just trying to make sure that there is enough money to pay everyone's salaries, which is nice because living indoors is pretty awesome. The third party here, the tag, is only doing its job either. They're just optimizing for their own business metrics. They want to make sure that they can pay their salaries by being the best third-party provider that they can be. But they don't really care about your user's experience. And the reason for that is that our ecosystem is broken. So I'm going to talk about the problem, talk about the fact that why these incentives are not well aligned. I will describe the current workarounds, the current ways to mitigate that impact with the tools that we have today. And finally, I'll outline a plan to actually resolve that and hopefully get the incentives of everyone aligned towards our users' experience. So, the problem. About a year ago, The Verge had an article about why the mobile web sucks. Sorry, Ian. And they were calling out the fact that mobile web pages are extremely slow and painful, mostly blaming mobile browsers for not trying hard enough. A Mozilla engineer replied in a blog post basically analyzing what resource The Verge were loading as part of their page. So it turns out that they were loading about 1 megabyte of data in order to show the content, which is hefty, and which is why Ian and Jason were talking about their performance issues and how they tried to make it better. But that's not the problem. The problem was with the 11 megabytes of resources that were downloaded afterwards by third parties. 7 megabytes of JavaScript. And that's 7 megabytes of gzip JavaScript on the wire. The browser then has to ungzip it into I don't know how many megabytes of text, parse it, run it, and keep it in memory for the lifetime of that tab. That's awful, and this is all third-party work. And as you may have seen in the previous session, Vox engineers care deeply about performance. They want to make their site as fast as they possibly can, but this is beyond their control. They have zero control over what third parties are doing on their site. And this is what we need to fix. So another study that recently came out is that 50% of mobile data plans are being spent on ads. And ads are getting worse. They're getting more intrusive. They're taking larger and larger chunks of the screen real estate. They play video and audio in the background, and they're doing all kinds of intrusive and annoying things to our users. And on top of that, there's the security risk of ad networks actually being used as attack vectors on our users. And what I'm about to say may sound revolutionary, but bear with me. I think that users don't really like it. This is a problem, and the way that users are fighting back, the way that they're tackling this is by applying ad blockers, which are browser extensions for the most part. And they are basically targeted. Browser extensions are targeted as a way for users to gain control over the content that they're seeing. And ad blockers are used exactly for that purpose. And users are installing more and more of them. And on top of that, some browsers are now installing native ad blockers. Like Bruce mentioned earlier, Opera is experimenting with a native ad blocker, which is way faster than the ad blocking experience that we have otherwise. And it uses less memory than Chrome is doing with ad blockers, so with extension-based ad blockers. And other browsers like Brave are also getting into that space, into that native ad blocking space. And ad blockers are getting installed more and more. iOS 9 introduced content blockers, which made them mainstream on mobile. And the response, so ad blockers are the way that users are fighting back. Embedders also see their users suffering. They see their users afraid of clicking links because we have trained our users that links are slow and expensive. And walled gardens, so embedders such as social networks and search engines have come up with their own formats in order to tackle that problem. So Apple came up with Apple News, Facebook with Instant Articles, Google with AMP, which stands for Accelerated Mobile Pages. And what these formats basically do is enable a distilled user experience. They force publishers to distill their content, kind of like what they used to do in the good old WAP days, if you're old enough to remember that. And AMP is particularly interesting as part of these formats because it's not a format of its own. It's a subset of HTML with a mandatory JavaScript framework up front and a bunch of custom elements replacing native elements because the native elements are not always mobile friendly in the way that they behave. But basically, you could create faster sites without AMP. AMP gives you a lot of tools that make it very easy to create fast websites. But you could create faster websites without AMP. There are costs to AMP, the framework that you have to download up front. But the main thing that AMP gives you, the main thing that other formats also give you, is guaranteed performance. They now enable you to make sure that your content will load fast, or they enable the embedder to make sure that whenever the user clicks on a link, it will load fast. It will not load in the ton of third-party content and the madness that runtime madness that pursues with it. Basically, users have been fighting back embedders have been fighting back, and advertisers got the message. So the IAB, the Interactive Advertising Bureau, have basically took that into account and came up with 2 new initiatives. One is lean, make sure that the ads are acceptable, they are lightweight over HTTPS, users can opt out, and they're not invasive for some definition of non-invasive. And another initiative called Deal that is targeted at publishers, which basically tells them to nag users into turning off their ad blockers. And this is, at least in my view, not necessarily a winning strategy to nag your users and then block them if they don't comply. So we also have new tech that is targeted at blocking ad blockers and actually displaying these ads counter to the user's expressed wishes, which is then obviously followed by ad blockers, which the new ad blockers are fighting and trying to block these ads nevertheless. And so basically we have a war, an arms race in the war on ads. And like most wars, the main people that profit from it are the ones providing the ammo. Moving to part 2, workarounds. How can we mitigate the negative effects of third parties? So the first step is async loading, either by using the async attribute on scripts if you're loading scripts, or by using the various async snippets that almost all third parties nowadays provide. This is the first step in fighting back, the first step in making sure that ads will not block your critical rendering path, will not block your parser. But it's not really the full solution. It doesn't provide anything beyond that. And at least in some browsers, async scripts will not get deprioritized in terms of network download. That means that async scripts, even though they don't block the parser and they don't block rendering, they will contend on the bandwidth with your own site's resource, with the first-party resources. So there is no real way to control that. Some browsers play around with deprioritizing these resources, but not all. So it's a good first step, but nowhere near a complete solution. The next step is pre-connect and preload, which are new link relations recently added to, as standards recently added to Chrome. I'm currently working on the WebKit implementation of preload as well. And they are, if I may say so myself, they're great. I love them dearly. But they are, so basically these link relations enable you to pre-connect to hosts that you know the browser is going to need to connect to later on. And preload enables you to preload resources that you know the browser is going to need later on. And they're great for static resources. They're great for hosts that are easily predictable. But the problem there with third-party content is that this is not always something you know. There are a lot of static, there are some static resources, but there are a lot of dynamic resources out there that change on each page load, and you cannot really know that in advance. There are dynamic hosts that change, and that's not always something you can predict ahead of time. Arguably, you could say that well-behaving third parties could have used these mechanisms to load these dynamic resources ahead of time because they, in some cases, have that info. So these are great tools, but again, not solving the entire picture. Service workers. which I'm sure you heard of, is also a standard that basically enables you to intercept all network requests and do with them as you will. One thing in the context of third party is that service workers can be used to prevent what we refer to as front-end single point of failure. They enable you to intervene if certain resources take too long to get a response from, so that you can basically return an empty response instead and release the browser from waiting on them, and because there's a good chance they're blocking some metric, either rendering or DOM content loaded or unload. So it enables you to take control over timeouts, for example. Service workers can also be used as a very crude mechanism for control. So you can count the amount of requests that a third party is issuing and have arbitrary rules saying that if this number of requests is exceeding X, you do something about it, you terminate these requests, you somehow have control over these requests, but you don't have control over the actual responses because they are third-party responses, not always with course enabled. The response itself is opaque, so you're not aware of the size of the response or its contents. So again, service workers are great. They enable you to do certain things with regard to third parties, but they are not the solution that we're hoping for. Framing. So iframes are pretty awesome. They enable you to isolate, basically isolate content from the context of the main document. That means that you can run third-party content without having to give it access to everything on the page, without having to give it access to your cookies, which is a significant security risk. So framing third-party content is a very reasonable thing to do. One problem there is that not all third-party content is easily frameable. A lot of third-party content requires access to the DOM, requires access to the main context in order to be able to determine the visibility of certain portions of the page. For example, with ads, they want to make sure that they're viewable, and therefore they need to know where the user is and what the user is doing. That's also opening up an avenue for a lot of potentially unwanted tracking that they can do if they're in that context. So one addition to iframe, which enables you to shut down third-party resources even further, is the sandbox attribute, which enables you to put all the content in that iframe in a sandbox that is not allowed to run scripts, not allowed to open model windows, not allowed to submit forms, et cetera, et cetera. There are a large set of restrictions on that content. Some of that may not be entirely reasonable. For example, forbidding third-party content from running any scripts is likely to make it irrelevant. So there are various opt-ins that enable you to turn on features for these sandboxed iframes. So, for example, allow scripts, but you can also allow form submission, etc. So iframe and sandbox are other tools that allow you to confine and mitigate the damage that third parties can do. And one framework that's being worked on by the IAB is SafeFrame, which actually enables you to provide iframed third parties some visibility into whatever's going on in your DOM without giving it the keys to the kingdom. So you're running the SafeFrame script in your main context, and it's post-messaging the info that the third party needs back and forth from these isolated iframes. So the iframe itself doesn't have access to the DOM, but it can request certain types of information which are relatively safe from this SafeFrame JavaScript. So this is a great tool to use wherever supported. But you need the third party to actively support that. So framing of third-party content is great, but there are still things that framed third-party content can do that is undesirable. So framed third-party content can still download as many resources as they like. They can hog the CPU, which is in many cases, in most browsers today, will still run on the main thread. So they can still have significant negative impact on your page, on your content. And again, they can contend on bandwidth with your content. Content security policy is another web standards that is, as the name implies, targeted at security, but enables you to do all kinds of cool things that are also related to performance. So you can only allow certain hosts in your page and block all uninvited third parties, for example. You can make sure that no video or audio will be allowed. You can enforce CSP rules for all your iframes. You can also make sure that you can apply sandbox policies, the same ones that we saw for iframes. You can apply them also for the main page's context. So if you don't run third parties if you don't run third parties in an iframe, you can still say that models are not allowed, for example. You don't want alerts anywhere. You can have all kinds of, basically trim down the capabilities of what the browser can do in order to make sure that nothing undesirable happens. So content security policy is great, but it's targeted at security, not necessarily performance. So it has some tools that we can use, but it doesn't include all the tools that we can use, all the tools that we need in order to make sure that third parties are performant. Are there any third-party providers in the crowd? I just spent 20 minutes deriding third parties, so no one's raising his hand. So theoretically, if there were, what can they do in order to make sure that they're good web citizens? What can they do in order to not abuse our users' experience, other than the obvious of not downloading a ton of data and not being too intrusive? Well, there are a couple of new standards that enable third parties to play ball with the browser and be less intrusive in their various tracking needs. So one of them is passive touch events. So touch events in general can be very destructive for runtime performance because the browser has to wait until the touch event script has finished running in order to know if the touch event is eventually canceled. And if it was canceled, then the action didn't take, and the browser doesn't need to act upon it, so doesn't have to scroll, etc. That is a huge problem when you're using touch events. So a recent addition is event listener options and passive touch events, which enable touch handlers to declare upfront that they are not going to cancel the touch event, which enables browsers to just carry on with the operation, with the action that the touch event triggers, and run that handler async in a way. So this is one thing that it's true for third parties, it's also true for first party content. If you have touch event handlers which don't require canceling of the touch event, you probably want to make them passive for the browsers that support it. If you have touch events that do require canceling, you're kind of out of luck because browsers are going to start enforcing passive touch events very soon on all content. So because we see a lot of touch events, a lot of lag related to active touch events, so you probably want to move away from active touch events in any case. Another interesting API related to third parties in particular is intersection observers. A lot of third parties, like I said, require some form of tracking, require some form of knowing which elements of the page are visible in order to know which ads are billable. And doing that nowadays, or doing that before intersection observers, required constant polling of all touch events, all scroll events, and making sure that you measure the layout, you measure the screen position of all the elements you care about in every time the user scrolls or touches their screen. And that is as bad as it sounds. It's very CPU consuming. It resulted in a lot of jank, especially because when you have 15 different third-party providers, all of them are measuring the same thing. All of them are adding handlers to the same scroll events, to the same touch events. That process takes a long while, and a lot of frames are missed. So intersection observer resolves that problem by adding a way to subscribe to certain elements and telling the browser to trigger callbacks whenever these elements are about to go into the viewport and about to be visible. And that enables to move away from the polling model from the scroll and touch handlers into a friendlier callback model. So particularly true for third parties, but also true for anything you're doing that is related to determining if things are inside a viewport. In particular, lazy loading of images can now start to rely on intersection observers. It's currently only supported in Chrome, but there is work underway for other browsers, and there is a polyfill being worked on as part of the standard. But we talked about a bunch of ways to mitigate third-party content, but what is the grand plan? How can we bring back peace to the galaxy and align all the incentives of everyone towards our users' experience? Well, if we look historically at proposals that were targeting the ad industry, do not track stands out as something we don't want to do. Who here is familiar with the do not track proposal? So a few people. That proposal was started back in 2009 or 2010 as a result of invasive tracking by various ad providers. And what browsers came up with is adding a header to the request indicating that the user has expressed their wishes not to be tracked if the user has opted in. Turns out that if you actively ask your users, do you want to be tracked, they will answer no. So, which is what IE10 did. which resulted in a huge spike in requests that actually have the do not track flag turned on. And as a result, the ad industry, which was previously leaning towards supporting this proposal, backed out and said that they're not going to respect that. So do not track is still being used today as a toothless request header that does nothing in particular. So the main lesson there is that if we want to add mechanisms to motivate third parties towards better behavior, these mechanisms have to be enforceable. Content security policy, on the other hand, which we discussed, is a very positive model where we can basically declare policies and the browser enforces them. The browser can act upon these policies and break content that doesn't comply. It also includes cool mechanisms like reporting mode, so you can turn it on in reporting mode and get violation reports without actually breaking user content. So content security policy was a very positive model when discussing various ways to get third parties to behave. So these two proposals is what I had in mind when I started blabbing about figuring out a standard alternative to AMP, figuring out AMP-like mechanisms that will enable us to guarantee performance. So a few months later, I put together a proposal called Content Performance Policy. The name actually came from various discussions with AMP engineers. They they came up with the name initially. And after a few conversations regarding the subject, after a few meetings with Chrome folks, with AMP folks, we decided to break it apart into 4 smaller proposals because the initial proposal included a lot of things which some are more feasible than others. So we decided to break it apart in order to be able to implement it gradually. The first step is a proposal being worked on by Ilya Grigorik and Mike West from the Chrome team called feature policy, which basically enables us to turn off bad features, enable us to turn off harmful features. And when I'm talking about harmful features, I'm mostly discussing features that halt the browser's UI thread, halt the parser, annoy the user, or anything in between. So the interesting part about this proposal is that it enables us to block bad behavior by third parties. It also enables us to block bad behavior by that other team that is down the hall and doesn't really care about performance as much as you do. So you can, instead of using code reviews and nagging as your methods to control that team, you can just flip on a policy that makes sure that the browser will enforce these conventions for you. And basically, if they will try to deploy any of these harmful features, the browser will break their pages, they will feel bad about themselves, everyone wins. So the features that we're mainly talking about related to performance in feature policy is avoiding synchronous scripts. We already discussed the fact that synchronous scripts are bad. They block the parser thread. It's not something that you want in your pages in almost all cases. So synchronous, you can use the feature policy to declare that no synchronous scripts are allowed in your page. Same goes for synchronous XHR, which is basically blocking the UI thread on network requests, and no one should be using it ever. Sync XHR usage is especially prevalent in third parties that are an old analytics script that are using Sync XHR in order to make sure that a certain request goes out before the browser turns off the page or moves it to the background. There is no real reason to use that nowadays. We have the Beacon API, SyncXHR should be gone, and this proposal enables you to guarantee that. Document write is another API that is used and abused by ads for various weird purposes, and is preventing the browsers from optimizing a lot of the stuff that they can be optimizing. So avoiding document write is always a good idea, especially since they are tied directly to synchronous scripts. You cannot use document write with asynchronous scripts. So the proposal's syntax to disable all these features is something like that. I don't think this is in any way the final syntax, but that's the current proposal. The main idea here is that the page declares a policy, and that policy gets propagated to all the child context, to all iframes in that page, and enables the main context to basically turn off all these features. There are a bunch of other security-related features that are discussed as part of the policy, but I won't go into that here. The second part of the bigger CPP plan is to enforce resource size limits, being able to declare policies by the first party that enforce, basically limit what that page, what the main context can download, and what iframes on that page can download. Also, probably will be related to resource types. So define how much JavaScript you can download and how much CSS, images, etc. We don't yet have a concrete proposal for that, but it will probably work in very similar ways to what the feature policy is doing. So it will probably enable you to declare a policy on the page and propagate it to child frames. Third part is CPU and bandwidth priority, and I'm running out of time. So CPU and bandwidth priority, basically, currently the browser is not aware of what content is important versus what content is not. Third-party content is running in the same priority as your own content. And you can also not differentiate between critical third-party content and not so critical. So Ilya had a proposal regarding C groups for the web, which enabled you to define priorities for priority groups and then assign these groups for various elements on the page. I'm not sure this would be the final syntax. This is a very early proposal, but this is definitely a direction, like something that we need to address and give the browser the tools to limit to limit parts of the content where, and avoid them, for example, hogging the CPU where they shouldn't be doing that. The fourth part, the trickiest part, is the user experience part because it's very fuzzy. There's no easy way to determine whether ads are annoying. So this is the part that we still need to work on. This is the part that Bruce also said that the IAB are looking into ways to enforce their lean requirements on various ads. We need to still think about that and see what heuristics browsers can apply regarding annoyingness of third-party content. And missing in action is the privacy part, because the part that do not track failed to tackle is actually pretty hard to tackle from a browser's perspective. The browser is not aware of any kind of tracking. Tracking happens on the server side. So this is practically out of scope for this effort. And what do we hope that these policies would enable? Where do we want the ecosystem to go? So First of all, we want control to return to the site owners so that they will have a saying with everything that is impacting their users' experience and will be able to guarantee performance. Once that happens, embedders can get smarter and can provide AMP-like SEO benefits for websites that guarantee that performance, for websites that have enough guarantees that satisfy the embedders, the search engine or social networks criteria for fast content. And I'm also hoping we would be able to have smarter ad blockers. So ad blockers that are blocking slow ads, that are blocking harmful content, but letting through ads that are respectful of the user's bandwidth, CPU, and hopefully experience. So the end goal here is happier users and aligning the incentives of the entire ecosystem towards that. So with that, thank you very much.